Hello, today we're going to be talking about how to solve systems of equations. Okay, so first off, what is a system of equation? A system is two or more equations with the same variables. Okay. Graphically, the point x comma y is where the two lines intersect. So that's what we're going to be looking at today, which 2 points cause those two, or which point is where the lines intersect. And then algebraically, that point is what makes both equations true. Okay, there are three types of solutions for systems of equations. The first type is intersecting lines. So if we have two lines that intersect like this, then the intersection is where the solution is, and that's just going to be a x value and a y value. Okay, if two lines are parallel, which we know from our notes last week, that means that they have the exact same slope. That means that there is no solution. If they are never going to touch, that means there's no solution. Sometimes you will see that the equations end up being the exact same line, one on top of the other, like this, and that will give you infinite solutions. So they touch in an infinite number of places. Okay, there are three steps to solve systems of equations. The first step is to get both equations in slope-intercept form. So basically, we want to make sure that y is by itself. Second, we are going to graph the equations. And then we can find the intersection. Okay, so if we look at this first example, we are already good on the first step because we can see that both of these are already in slope-intercept form. So let's go ahead and graph the top line. I'm just going to do these in two different colors so you can keep up with what I'm doing. I'm going to do the top one in pink. Okay, so this line has a m of 1 and it has a b of -8, right? So I'm going to start my graph here, 1, 2, 3, 4, 5, 6, 7, 8, at -8. And then I have a slope of 1 to continue my line. Okay, so that is going to look like that. Okay, now I'm going to go to my next line. I'm going to graph that one in, let's say, blue. Okay, this one has a slope of -2 and a b of +1. Okay, so I'm going to start my graph at +1, and then I'm going to go down to right 1 in order to finish out my line. It looks like this. Okay, my solution is where these two lines intersect. So this green dot right here, that is going to be my solution. Okay, so the solution is 1, 2, 3. My x value is 3, 1, 2, 3, 4, 5. 3, -5. Okay, and that's the point that makes both of these equations true. And that's where they intersect on the graph. Okay, looking at the second example, okay, my first line has a slope of 1/2 and it has a b of 9. Okay, so my graph is going to start up here at 9 and then it's going to go up 1, right 2, or down 1, left 2. Okay, so that is our first line. And then our second line has a slope of -1 and a b of 6. Okay, so 1, 2, 3, 4, 5, 6. So our second line looks like this on the graph. So again, I'm going to make my solution here in green. This is the point that the two lines intersect. So that is going to be where my solution is. So in this case, that is -2, 8. Great, let's see a few more examples. Okay, sometimes you are going to have to get y by itself. Sometimes it's not going to already be solved. So let's look at this first one on number 3. We have -3x plus y equals 8. We need to add 3x to both sides. That gives us y equals 3x plus 8. Okay, so that graph has a slope of 3 and a b value of 8. We'll go ahead and get that on the graph. Okay, starting the graph at 8, going up 3, right 1, or down 3, left 1. Our second graph, we again have to solve for y. We have -x plus y equals -2. So we need to add x to both sides. We end up with y equals x minus 2. That gives me a slope of 1 and a b of -2. So I'll start that graph here at -2. Okay, and then I can have my +1 slope be like this, down, down, okay, like that. Oops. Sorry, my line's a little crooked, but you can still see where the intersection is right here. Okay, so that's going to be 1, 2, 3, 4, 5, -5. 1, 2, 3, 4, 5, 6, 7, -7. Okay, so that would be our solution here. Okay, let's drop down here. Our first line on the second example, x plus 2y equals 4. So I would subtract x from both sides. 2y equals -x plus 4. And then I would divide everything by 2. So I have y equals -1/2 x plus 2. Okay, so I start it here at 2, -1/2. I go down 1 to the right 2, or up 1 to the left 2, like this. Okay. And then after I connect these dots, if you take a peek, you can see that my second line is exactly the same. I have a slope of -1/2 and I have a b value of 2. So that line would be the exact same line as my pink line, which means that I have an infinite number of solutions because this graph, every single point on the line touches. Okay, couple more examples. I can see here I have my first line, x plus 3y equals -15. Subtract x from both sides, I get 3y equals -x minus 15, divided by 3, divided by 3, y equals -1/3 x minus 5. Okay, so I'll start my graph here at -5, and then continue the line with a slope of -1/3. Can go down to the right or up to the left. Go ahead and connect those dots. And then my second line says y equals -7. If I just do a quick sketch of my slope guy, he has an undefined nose with his X nose piercing, a 0 mouth with his Y tongue sticking out. That Y tongue sticking out tells us this is going to be a horizontal line at -7. So I just go down to -7, 1, 2, 3, 4, 5, 6, 7, and then I'm going to have a horizontal line that goes through at -7, okay? And that guarantees to me that my y value is going to be -7 because every single point on this graph has a y value of -7. Okay, it's guaranteed. Here's my solution. So I just need to worry about my x value, which is 1, 2, 3, 4, 5, 6. Okay, 6, -7. Let's look. Let me see if there's any other important ones to show you. Okay, let's look at number 6. Okay, here I have y equals x plus 5. So I don't have to solve for anything. My slope is 1. My b value is 5. So I will start this graph at 5. I'll go up 1 over 1. I like to go 2 over 2 to kind of make it go a little faster. Okay, and then here I am going to have to solve for y in the second example. So I'm going to subtract x, negative y equals negative x plus 2. Then I have to divide everything by -1, and I get positive x minus 2. Okay, so here my slope is also 1, my b value is -2. I'm going to start that graph here at -2, and then I'm still going to have a slope of 1. Okay, if you remember, lines that have the exact same slope, which these lines do, they both have a slope of 1, they are going to be parallel. If they are parallel, that means that there is no solution. Okay, there is no solution because there is no place that those two lines touch each other.